Hello YouTube, welcome to my channel. In this video I'm going to demonstrate the application of a microcontroller in an RC vehicle or toy, whatever you want to call it. In this case I have this chassis which is acting as an RC vehicle that is controlled by the Atmega 324, which is interfaced with a Bluetooth module for connectivity purposes, and also interfaced with the motor drive right here, because apparently these motors require more power, more than what the chip requires. So there has to be a medium of connection between the Atmega 324 and the motor drive. You can't connect them directly. So this one issues the control and this one issues the power to the four motors that are in here. So anyway, let me jump quickly to the code that I did in Atmega Studios. Let me just walk you through it. The code is pretty simple. I have the includes, 3 includes only here, interrupt, and this Bluetooth serial, which is right here. I think I used somebody's library, I'm not sure, but it's a standard library for USAT. You can get it from the internet. It's readily available. And there is a serial puts string function and so forth, but the main controller is this one right here. So I have some prototypes here. I have to initiate the PWM for controlling variation of speed, because this RC can be controlled using different speed. It doesn't have to be just one speed. And then there's this prototype saying set speed. You give it a value, and in return it scales that value to produce a PWM. And of course there are these other functions: forward, reverse, motion, stop, left turn, and right turn. In the main function, I declare a char code data for receiving the character, and I also have a char for the mode. I can have M signifying manual, and also the manual as default, as by default, and this can also, the mode can also be auto with the character A signifying auto. And I have unsigned int receive duty cycle, and another unsigned int speed, which is set to 0 initially. I'm setting the direction data register A as an output. This is where all the control to the motors are connected, and I set it to 0 so it doesn't start high. And here I initialize the PWM. We're gonna look at it down there. I also initialize the serial by giving it the baud rate right here, and of course I enable the
enable the global interrupt. In the while loop here, I'm receiving data from serial and passing the data to see what is contained using the switch statement. So switch data, and of course in the options that this data might contain. And F for forward, if it's an F, then I should call this forward function per se, and clear the data receive break out of the switch statement into the while loop. If not, if I receive an error, then an error character, then I should call the reverse function, and so forth. The left L, I should call the left 10. T, I should call the right 10. And if I receive a B character, then I should stop the motion. In case I receive an A character, then I should set the mode to character A. And if I receive an M, then the mode should be set to M, and so forth. That's the while loop. In the same while loop, if I happen to if the mode happens to be equal to A character, then I need to set speed equals to the maximum duty cycle value, basically, and reset the received duty cycle to 0, and then pass this speed value to the speed function, which runs off the PWM. Otherwise, if mode is M, speed is equals to 0, then I need to receive the value, the duty cycle from the serial. That this needs to be sent by the app. And if the this duty cycle must be between the value of 0 and 255, then I need to set the speed with the received duty cycle, and at the same time transmit back the duty cycle to the controller. And this is the end of the main function. It's quite simple. Down here I have the init function. It's basically setting up a PWM and so forth. The prescaler, the frequency at which it must run, and so forth. And then I also have the set speed, which is just receiving the duty cycle and passing it to the 0CR2 register. Output compare register. I also have these functions. They set forward, motion, reverse, and so forth. Everything is pretty simple and straightforward. There is nothing complex. So for the sake of demonstration, let's go ahead and open the app that controls this RRC that I made on Android, for Android PC, and it looks something like robot car right here. I launched that. It's opening up, and once it opens, it looks something like that. It's a simple app with 4 arrows and a stop button in the middle, buttons to connect and button to disconnect, and a check button to pick between auto and manual. As you can see, the default is manual, so I'm gonna go ahead and try to connect to the Bluetooth module that is on here, and on this list it must be the one that is ending with HC5. That one right here is taking some time, and it's connected.
we have this Bluetooth connected to that, so that thing is ready to receive the commands. So I'm gonna go ahead and pick the auto, that is run on maximum speed, and then give it the forward go forward and then go backward. So yeah, this is a quick video I wanted to share with you guys, and if you like the video, please give a thumbs up, and if you have any question, feel free to leave a comment below. Thank you for your time.